All right, so number 28, given the explicit formula for the geometric sequence, write the recursive formula. So number 27, I did go through the details of both the explicit and recursive formulas for geometric sequences. So if you feel like you need a refresher on those, just go back to the last video. When we have an explicit formula, we just want to recognize the parts that we're given. So this number out in front is always going to be our first term. So that's our A1. This number in parentheses that has this exponent of n minus 1 is our R value. That's our common ratio. All right, if you know your first term and your common ratio, that's enough information to write either an explicit or a recursive formula. So recursive formulas have the form an equals R times, so you would take your common ratio, multiply it by a with a subscript of n minus 1, and then we add on a little tagline with a1 equal to whatever the first term is. So the way that a recursive formula works is you take this a sub n minus 1 stands for previous term. So you take whatever your previous term is and you multiply it by your common ratio. That's how you get to your next term. You take the previous term, multiply it by your common ratio, but we do have to tell people where to start. So we give them a starting point, and then they know to continue to multiply the previous term times a common ratio. So we are going to follow this structure and fill in our information. So our recursive formula is going to be a sub n equals, the r is a -4 times, now this a with a subscript of n minus 1, that's the same in every recursive formula. So this will always be there. Don't change that. We just have to figure out the r value. And then we add on with a1 equal to, and we can see over here that our a1 was equal to a -2. And this is a recursive formula. All right, number 29, graph the function 2 to the x power minus 3. So what we're going to do is we are going to write a table of values for f of x equals 2 to the x power, and then this minus 3 on the end tells us to shift our entire graph down 3 units. But we will start by just getting a table of values for 2 to the x. So when you guys need a table of values, you can use your graphing calculator. Just go to your y equals, type in 2 to the x power, and we're just going to grab some ordered pairs from that table. Typically, we do a -2, -1, 0, 1, and 2 for the x's. And then if we look at our table of values from your graphing calculator, you'll see that if you plug in a -2 for your x, 2 to the -2 power is a 0.25. 2 to the -1 power is a 0.5. 2 to the 0 power is 1. 2 to the first is 2. And 2 to the second is 4. Now again, we are just graphing the function without the translation, and then we will shift everything down 3 once we have our points plotted. All right, so I'm going to zoom in here a little bit to plot these points. That first one was a 0. I'm sorry, it was a -2.25, so kind of small right there. Then we have a -1, +1/2, 0.5, 0, 1, 1, 2, and then 2, 1, 2, 3, 4. So if I were to even kind of sketch in this graph, here's our function before any vertical shifting. This function does have the asymptote at y equals 0. That's our default asymptote. But if we have vertical shifting, all of this is going to move up or down. So now let's take everything and move it down 3 units. I am going to start with the asymptote. That's going to go down 3 units. So at y equals -3, this is the asymptote for our graph. And then point by point, let's just move those down. I will use, I don't know, I guess red. All right, so this point right here is going to go down 3 units to right here. Then this point is going to go down 3 units to right there. We got this point that we plotted down 3 units. Then this will go down 3 units, and then this will go down 3 units. So we'll just plot those points. And then we'll draw in our new curve that is the same, just shifted down 3 units. And that's how we can graph an exponential function with a vertical shift down 3 units. All right, number 30, we are getting into our factoring. This is our most recent unit. All right, so factoring, first step, we look for a GCF. Do we have a GCF for these 3 terms? We do not. We notice this is one of our x squared trinomials, ax squared plus bx plus c. Then we notice that this is only an x squared. There's not a number in front of the x squared. So that means we can do our factoring by starting with our c value. We're looking for factors of 54 that add up to our middle term of 15. So factors of 54, 1 and 54, 2 and 27, 3 and 18, 4 is not a factor, 5 is not a factor, but 6 is a factor, 6 and 9. And those are all of our factors of 54. Now what we're looking for is the factor pair that adds up to our b value of positive 15. And if we go through and add all of our factors together, we're going to see that 6 and 9, that's the factor pair. 6 plus 9 is 15. Once we have our factor pair, we can go right to our 2 binomial factors. Our first one is going to be an x plus 6, and the other one is going to be an x plus 9. Every time we factor, if I were to multiply these 2 binomials out and combine like terms, we would get back to what we started with, x squared plus 15x plus 54. All right, part B, another factoring problem. Look for a GCF first. There's no GCF. It's an x squared trinomial. There's not a number in front of the x squared, so we get to jump right to our c value and say what are factors of c, which is 9, that add up to our b value of negative 6. So factors of 9 are 1 and 9 and 3 and 3. So we're looking for a factor pair that adds up to negative 6. So now we have to think about the signs. These positive factors multiply to a positive 9, but we need them to add up to a negative 6. So to still get factors that multiply to a positive 9 can both be positive or both be negative. So let's consider these negative factors. And this is the one I'm zoning in on right here. Negative 3 times negative 3 is positive 9. That's the first criteria it has to meet. But then negative 3 plus negative 3 is negative 6. So that is the factor pair that we want. So we write it as our binomial factors, x minus 3 times x minus 3. And then we might notice, oh, it's the same binomial factor twice. So x minus 3 times itself. We can go ahead and simplify one step further and say that's the same thing as an x minus 3 squared. All right, number 31. Start by looking for a GCF. There is no GCF, but you might notice, oh, we've got these y's in here that our first 2 examples did not have. So that's okay. I'll show you how to take care of the y's, but there's no GCF. Then we say it's an x squared trinomial. So it has an x squared and then an x, and then this term of just the 20. Again, there is this additional y and y squared, but I'll show you how the y's come into play. Do we have a number in front of the x squared? We do not. So we can jump to factors of c that add up to b. Now, because we have that y squared with the 20, it might be easier to include the y squared when we're looking for factors of 20 that add up to 10. So the more that you guys factor, the faster you will get to your factor pairs. So I could write out all my factor pairs of 20 Or I might think about it for a second and say, oh yeah, 10 and 2. So I'm going to say 2 and 10, but to get to a y squared, I'm going to say 2y and 10y. 2y times 10y is 20y squared, and that 2 plus the 10 gets us that 12. So that is the factor pair that we're looking for. We can go ahead to our two binomial factors. This is still going to start out with an x, but instead of saying x plus 2, we're going to say x plus 2y, and then x plus 10y. And those are our two binomial factors for that trinomial. All right, part B, we can take that same approach. Again, we start by looking for a GCF. There's no GCF. It is an x squared trinomial, so we can look for factors of c that add up to b. Again, our c value has a y squared included, so why don't we include the y squared when we're trying to find our factors of c. This just means our factors will have a y with each factor pair. All right, so we're looking for factors of 14 that add up to a negative 9. So factors of 14, 1 and 14, 2 and 7. The 2 and 7 is where we're going to head with this, but we're going to say 2y and 7y, and then let's just take a look at our signs. Our two factors have to multiply to a positive 14y squared, so our factor pairs can be positive, but a positive 2 and 7 do not add up to a negative 9. So we can make each factor pair negative. The negative times the negative is still a positive 14. And now the two negatives add up to this negative 9. So we did need those two factor pairs to be negative. So our binomial factors are going to be x minus 2y times x minus 7y. All right, number 32. Factor 4x squared plus 28x plus 40. So start by looking for a GCF. A quick thing I look at is whatever our smallest number is for a factor of 28 and 40. If it is, then I know that 4 is part of a GCF. So 4 is a factor of 28, and 4 also is a factor of 40. So we do have a GCF on this one. Our GCF is 4. Do we have any x's? Do all three terms have x's in common? Nope, so just the 4. So we're going to start by factoring out the 4. Now when we factor out the 4, we're going to factor a 4 out of every term. And inside our parentheses, let's put what we get when we factor that out. So 4x squared, factor out of 4 leaves you with just the x squared. 28x, factor out of 4. So factoring is like division. So we can think about 28 divided by 4 is 7. So plus 7. And we have an x, but we're not factoring any x's out. So we still have an x with the 7. Plus 40, factor out of 4. So 40 divided by 4 is 10. All right, now that we have factored out our GCF, we do want to keep thinking. Well, actually, let me remind you guys, when you factor out your GCF, you want to take a look at what you have left after factoring out the 4. Just as a quick double check, do these three terms have anything in common? If they still had a common factor after I factored out my GCF, that would mean that this GCF, there's actually more that we could factor out. So we actually didn't find the greatest common factor. So we'd want to go back and rethink that GCF. But I feel good with the 4, x squared plus 7x plus 10, no common factors. All right, so now can we keep factoring this trinomial? So let's just focus on the trinomial. It's an x squared trinomial. There's not a number in front of the x squared, so we are going to look for factors of c that add up to b. So what are some factors of 10 that add up to 7? 1 and 10, 2 and 5. So the 2 and 5 add up to 7. So we're going to use the 2 and the 5 in our binomial factors. X plus 2 times x plus 5. And then don't forget, any GCF that we factored out is a factor of our polynomial. So that has to be included in the answer. So that 4 is going to get carried down. And there is our factored form. All right, 32b. First, anytime we factor, what are we going to do? Look for a GCF. Do these terms have any common factors? They do not. So it is an x squared trinomial, but what's different is there's a 2 in front of the x squared. This 2 is a little different than this 4 over here because this 4 ended up being a GCF we factored out, leaving us with the x squared. But this 2 is not a GCF. We can't factor out the 2, so we have to consider the 2 in our factoring process. So when you guys are factoring and you have a number in front of your x squared, your a value, we are going to factor using the box method. So why don't we start by setting up our box. The first term, 2x squared, goes in the upper left, 2x squared. The last term, negative 15, goes in the bottom right box, negative 15. All right, so now we can't look for factors of factors of c that add up to b. We won't find any factor pairs that work. We have this extra step. We have to do a times c. So a times c is 2 times negative 15, which is negative 30. That's the number we want factors of. Factors of negative 30 that add up to our b value of negative 1. So if we go through and list all of our factor pairs, 1 and 30, 2, 15, 3, 10, 5, 6, the 5, 6 factor pair is the one that we're going to focus on. Now, 5 and 6, to multiply to a negative 30, we have to make one of them negative. A nice little rule that we can follow is the larger factor, if you need to make one of them negative, the larger factor will have the same sign as your b value. Since the b value is negative, I can make the 6 negative. And now this is our factor pair that adds up to a negative 1. So we're going to use this factor pair. We're going to go back to the box and we're going to fill in a 5x in one box and a negative 6x in that second box. All right, so now all we do is we factor out GCFs from each row. So what can we pull out of this top row? 2x squared and 5x have an x in common, so we're going to pull that out to the side. Negative 6x, negative 15. General rule of thumb, if both of these are negative, let's pull out a negative factor. And then what fits into a negative 6 and negative 15? That's going to be a negative 3. Now let's pull a GCF up to the top. We have a 2x squared and a negative 6x. So we can factor a 2 and an x out of both of those. And then our last column here, what can we factor to the top? 5x and negative 15. We can factor a 5 out. Now, let's just double check our signs and make sure that this all fits. Sometimes we have to adjust our signs after we factor out all these GCFs. So, is 2x times x 2x squared? That is, so we know that these are positive. We're not going to change those. Is a positive 5 times x this positive 5x? So that looks good. How about this 2x times this negative 3? Is that a negative 6x? That is, so that looks good. And then 5 times negative 3, is that negative 15? That is. All right, so I feel good with everything we factored. So now let's put our final answer together. This 2x and this 5, that's one of our binomial factors, 2x plus 5. And our other binomial factors is x minus 3. And now we have factored our trinomial.